Hello there, welcome to this video on Z-scores. So this is going to be the first video that we do on Z-scores. There's going to be a couple after this as well that we go into a little bit different types of questions. So with Z-scores, the reason these are called Z-scores is because the normal distribution that we've looked at from before that had that bell curve, that is also known as the Z distribution. So those different values that we're getting on our normal distribution, they're like scores, so we call them Z-scores. So a Z-score for a particular data value is the number of standard deviations the data value is above or below the mean on a standard normal distribution curve. And a standard normal distribution curve is just a bell curve with a mean of 0, so the middle is at 0, and a standard deviation of 1. So that means this is 1 unit, 1 unit, 1 unit, and this would be down 1 unit for each of those hops. So it says a credit card company records the length of time in days it takes for an adult between the ages of 18 and 24 to be approved and receive their credit card. The data is recorded on a normal distribution curve, so that's again this kind of bell curve, with a mean of 14 and a standard deviation of 2. So let's just write those out. So the mean, remember this mu, that stood for mean. So our mean is 14 and our standard deviation is 2. And our mean, it always went in the middle. And then to get to the next points, what we had to do if we went up, we had to add 2. So 14 plus 2 is 16. Add another 2, we get to 18. Add another, get to 20. And then if we want to go down, we just got to subtract 2. So that'll give us to 12, 10, and then 8. And then I'm just going to write below that, this, if it was our standard normal distribution, it's going to have a mean of 0 in the middle. So I'm just going to put a 0 there. And then this is 1 standard deviation, 2 standard deviations, 3. And then if you go down, it's going to be -1, -2, and then -3. So the reason why Z-scores is going to be useful is because if I ever asked you to say, tell me the percentage that is in this region right here, we knew that that was going to be 50%. Well, what if I gave you something like this? With Z-scores, you're going to be able to figure out what this percentage of area is without having it being exactly on one of these points down here. So what we're going to do next is fill in this chart here using this right here. So it says for the data value 18, we're going to figure out the number of standard deviations from the mean. So 18 was 2 standard deviations. So I'm going to write in there that was 2 above the mean. And then it asks above or below in this next question. Well, I just said that was above. And then the Z-score, because it was 2 standard deviations above, it would be a 2. Then looking at 8 is way down here. That's 1, 2, 3 hops from the standard deviation, and that is below the mean. So our Z-score would be -3. If you want to pause the video and try to attempt to fill this all out yourself, you could do that now. So for 14, this one might be a little tricky. 14 is right in the middle. So the number of standard deviations from the mean is 0. It doesn't move up or down. And then this question kind of doesn't make sense, so we can just put not applicable or put a mark through it. And then the Z-score for that would be 0. Looking at 20 next, that one was 3 above. So our answer for this one is, again, above. And then our Z-score would be a 3. And then the last one, a 12, that's just 1 below. So 1 below, and that's a -1. Next, we got this question here. It says, what do you notice about the Z-scores above the mean? So all the ones that were above, like this one, we got 2. This one was above, we got 3. What do you notice about all of those Z-scores? So when I look at those, I see that they are all positive. So let's write that. They are all positive. And then asking the question, what do you notice about the Z-scores below the mean? All of those ones that we had up here that were below, they were negative. So I'm just going to write that. They were all negative. So these values above the mean are positive z-scores, and then all of these values below are negative z-scores. So moving from there, we got our next example, example number 2. It says, on a math quiz, each student's z-score is recorded instead of a mark. Robert's quiz has a z-score of 2.8 and Ashley's quiz has a z-score of 1.2. How did Robert and Ashley do in comparison with the class average and also with each other? So I'm going to first put their information on this normal distribution right here. So in the middle is 0, and then this is going to be 1 standard deviation, 2, and then 3. And then you could also go downwards as well, but we actually don't have any negative z-scores that we're dealing with. So let's plot Robert's z-score first. His z-score was 2.8, so that is quite close to 3. So I'm going to put a little mark in here. That is where Robert's z-score is. Then we had Ashley. Her z-score was 1.2. So it was quite a bit lower. So down here at 1.2, that's somewhere in there. We're going to put Ashley. So to answer the question of who did better in comparison to the class average, well, the class average is right in the middle. So Ashley did above class average, and Robert also did above class average, but Robert did even better than Ashley. He is further away from the mean. He is higher up, so he got an even better mark. So let's write that out. So again, both are above average, but Robert, he's even farther from the mean, so he did the best on this quiz. Looking at the next thing there, it says calculating z-scores. So this is the formula actually for how we are going to calculate z-scores. So a z-score is equal to taking x minus mu and then dividing by sigma. So those three things, we've seen mu before, that is just our mean. And we've seen the sigma. Sigma was just our standard deviation. And the x there, that just stands for a data value. So whatever data value you're dealing with, that's what the x is going to be. So I'll kind of explain how this formula actually works. So imagine that your standard deviation, the sigma there, is your size of your step. So if your size of your step was 1 foot, let's say you moved over 1 foot, this would be 1 foot over. If you took 2 steps, you'd be here at the 2 foot mark, and so on. So the standard deviation kind of determines how many steps it's going to take to get to the location you want to get to. Now x, if I were to place an x on here, let's say I put x right there. So I'm going to move from the middle over to the x. Now I need to first know this distance, how far that is, and then depending on that distance, if it's longer or shorter, it's going to take me less steps to get there. So what you do is you take your x value, you subtract off whatever the mean is, that's the middle, and then after you divide that by the size of your step to see kind of how far over it is. So that's what this formula actually kind of means. If that didn't make sense, it's not the end of the world. As long as you know how to apply the formula is really all you got to know. So next here we got our first example with z-scores. It says we got mu is 112, the standard deviation is 15.5, and then the x value is 174. So we are going to find the z-score from this. So our z-score, just using the formula, is x minus mu divided by the standard deviation. So filling that in, x is 174 minus mu, that was 112, and then take that and divide by our standard deviation, which was 15.5. So make sure you always subtract these two in the numerator there first. So when I subtract those, that's going to give me 62 divided by 15.5. And when I divide that, I'm going to get 4. Now, if you ever get a decimal at the end, make sure you always round your answer to 2 decimal places. This is going to be needed for later when we look at a z-score table. It goes to 2 decimal places, so always round to 2 decimal places. Looking at this next one, We got our values right there. So again, we're going to start with our formula. Z is equal to x minus mu divided by the standard deviation. So x in this case is 47.28. Subtract off mu, which is 53.46. And then all of that is being divided by the standard deviation, 8.24. So I'm going to first subtract in the numerator. When I subtract those two, you're going to get negative 6.18. And then that's still being divided by 8.24. And then when I divide by 8.24, you get negative 0.75. And that one I didn't have to round. But again, if you have to round, always to 2 decimal places. So just by looking at the sign of these two, this one was negative, this one was positive. Remember, if it was positive, this means it was going to be on the left side of the mean in the middle. And this one was negative. So if it was negative, we're going to be on the right side of the middle. So those two are both done. We're going to move on to our next question here, which is an application question. So example 1, it says Tony's midterm marks are shown below. So we got a table down here. It says together with the class mean and standard deviation for each subject. So he's got his math subject, there's his mark, the mean mark for the class, and then the standard deviation. And then same thing for physics. It says by calculating z-scores, determine in which subject Tony performed best relative to the rest of the class. So when it's relative to the rest of the class, that is where your z-score is going to be important. So that's going to tell you how far you are off from the mean. So let's calculate his z-score for math first. So z is equal to x minus mu divided by standard deviation. So z is going to be equal to, x is his mark, so that's a 70 for math, so it's going to be 70 minus the average, which was 68, and then divided by the standard deviation, which was a 12. And when I calculate that, just again, make sure you simplify the numerator first. You're going to get 0.16 repeating. And I just got to fix my line here. It's just a line over the 6. Just the 6 is repeating. So it's like there's a 6 continuing on, just keeps going. So if we round that to 2 decimal places, this 6 is going to round up that 6. So we're going to get 0.17. So now we just got to calculate the z-score for physics. So again, x minus mu divided by sigma, the standard deviation. So x is 68. So we got 68. Subtract the mean, that was 65, and then divide that by the standard deviation, which is 11. And when you calculate this one, you are going to get 0.27 repeating. Both the 2 and the 7 are repeating, so it's like this, 27, 27, and it just keeps going and going like that. And this 2 is not going to round up that 7, so you're just going to get z equals 0.27. So if I were to plot this on my normal distribution, the middle is at 0, and that's 1, 2, 3, and then this is negative 1, negative 2, negative 3. 0.17 is just after the 0. It's really, really close to 0. So that is where his math mark is going to be. And then for his physics mark, that was at 0.27, so that's just a little bit further. So his physics is a little bit further ahead. So if we want to describe what's going on here, the average is right here. For math, he is above average in his class, and physics, he's even better. He is also above average in physics, but he's even higher than he was in math. So therefore, his physics, that's the one that he performed best in. So example 1 is now done. Looking at example 2, it says the weights of a large shipment of cantaloupes are normally distributed with a mean of 2.3 kilograms. The weight of a particular cantaloupe is 1.7 kilograms, so that's going to be like our x value. And then it says which is 1.01 standard deviations below the mean weight. So if we're below, that means we're going to be on the negative side, and that's going to be our z-score. So we're going to have a negative z-score of 1.01, and then it asks determine the standard deviation to the nearest hundredth. So the standard deviation, that's going to be like our question mark. So let's write in all that information. Standard deviation we are finding. The z-score below meant that it was going to be negative. So this was negative 1.01. The mean, it said, was 2.3 kilograms. And then the cantaloupe weighed 1.7. So that's our data value. So let's start with our formula. Z is equal to x minus the mean divided by standard deviation. And then we'll plug in everything we know. So Z is negative 1.01. X is 1.7 minus mu, that's our mean, 2.3, all divided by the standard deviation, which we don't know, so we just keep it as the symbol. So I want to solve for this, so we're going to have to isolate and get that by itself. So currently it's in the denominator, so to get it out of the denominator, we have to multiply by itself on both sides. So I'm going to multiply by sigma, and then on this side I'm also going to multiply by sigma. On this side they're going to cancel, and on the other side it's just going to be negative 1.01 sigma, and then equals. We can subtract these two in this step right now. That's going to give us negative 0.6. And then to get rid of this negative 1.01, we can just divide by negative 1.01. Just do it on both sides. And on this side, they will cancel out. So all that we have left is sigma on this side. And then on the other side, those negatives are going to cancel. So we just got 0.6 divided by 1.01, and that's going to give me 0.5940 and then some other decimals. And in this question, it asks us to round to the nearest hundredth. So we want this one right here. The 4 is not going to round that up. So our standard deviation is just equal to 0.59. So that was our last question. At the bottom here now, we just got our textbook questions. So we're on page 292, we got 1AC and then 10 and 12.